for the introduction. As was said, my name is Peter Lenz. I am Senior Geospatial Analyst at Dstilery, Inc. We are an ad tech and martech company. I was asked to do a couple of interesting statistics on the size of the company and what we do at the very beginning. We pull in event data, and those events can be a person seeing an ad on a web page, a pixel being fired, a person showing up at a location. That's the world that I live in, the location data, or any one of dozens of other inputs. And every day we collect about 200 billion of those, which blows my mind every time I say that number. I started 4 years ago, and I remember the party that we had when we had our first 1 billion input day. And to be at 200 just blows my mind. Somewhere around 25 petabytes of data in our data store. Majority of that is sitting in Hadoop with Cassandra, Hive, and a little tiny bit of Spark. We're a really early Hive user. We love SQL data. Somewhere between 2,000 and 5,000 servers, and that's a very big range, and that is because literally as I'm standing here, our infrastructure people are building a new cage in New Jersey, and I literally have no idea how many servers are running it now. And we run all of our own systems. We work in a world where the average event has a timeout. We have to have our machine learning generate a response on that event in 250 milliseconds. Most of that time is actually going to be spent traveling back and forth, literally in the wire, the packet travel time. My geospatial component has a 15 millisecond timeout. You can't do that on any kind of cloud. We build our own servers, we run our own cages, we wire our own networks. It's a lot of fun and cool custom stuff. When we talk about what tools we use, it very often comes down to, oh, we had to build a custom thing for that. Oh, we had to build a custom thing for that. Oh, we had to build a custom thing for that. And that gets annoying when you can't talk to other people about the tools they use. Luckily, we don't have that problem today. Today, I'm talking just about data. Geodata, my favorite kind of data. And it tells you the kind of person I am that I really get excited about that. In fact, we're going to talk about the most common kind of geodata, which I guarantee you have in your database somewhere else. I am talking, of course, about the zip code. It's everywhere. It's on your envelope. You can collect it just from mail. It's in every form that you have ever filled out on the internet. And how many times, I can't tell you how many times I've shown up in my stock photo supermarket and been asked, can you have your zip code, sir? Zip code utterly surrounds us as a piece of data. And it's amazing for something that is so ubiquitous that so few people actually understand what it is. Its caveats, the problems with it, and also the great things about it. We just use it because, you know, cultivated laziness is a really great thing to be. That's one of the virtues of data science. So we're going to do a fun little trip through zip codes. I think it's fun. We're going to go, to do that, we have to go back. We got to go way, way back to the beginning and understand how we got to where we are, where this data comes from. And as these things tend to go, when you're talking about some kind of something that's a piece of data being generated by the government, US government, it starts with one person. Benjamin Franklin, Mr. $100 bill, statesman, scientist, playa, Assistant Postmaster General of His Majesty King George III's possessions in the northern part of the Americas. A job which he took not so much because he wanted the job, but because it let him be a censor. What things got censored? Well, things that newspapers published by Benjamin Franklin, not censored. Newspapers not published by Benjamin Franklin, censored. Government corruption, it goes way, way back. That said, Franklin did actually do real work. He set up the very beginning of the postal system here in America. an infrastructure called the post roads. You've almost certainly seen one of them. They'll be called Albany Post Road, Boston Post Road, Charleston Post Road. They're routes along which the mail traveled. Back in the early days of the postal system, if you didn't live on these roads, you didn't get the mail. You had to travel to one of the points on this network to get it. The mail was carried by these guys, postal riders. The hat is a top hat that would eventually become the cowboy hat, which I think is really, really cool. And they would carry these giant horns, which they would blast when they got to town irregularly. In some places, like Philadelphia or New York, you'd get mail from someplace every day. But if you live in the backwoods, it might be months between these guys showing up. When the mail got there, it was a big deal. And they'd bring it to the post office. Except there was no post office. You'd be brought to the village inn or pub. Guy would literally haul the mail in. You can see him coming through the door here with a big bag of mail. The postmaster would be the innkeeper or the publican who's running it. And he's a really important person. In the early American Republic, every single postmaster was in fact appointed by the President of the United States for a very good reason. This is a very early implementation of peer-to-peer networking. That bag containing that mail, they're going to open it up, and together the postmaster and the post rider are going to read through it, and they're going to say, oh, this one's for here, this one's for there, this one's for here, this one's for there, and they're going to decide who gets their mail. Each node in this system has to be really, really smart. And there's no other form of communication. There's no telephone system, there's no telegraph system. This is it. If it's not done right, the entire communication system of the United States breaks down. Really, really important system. But every single piece of it has to be really, really smart. If you're going to be sending a piece of mail, you're going to address it something like this. If you're going to send it, we're going to take a look at all of the addresses that Dstilery has had through the years, if theoretically the building was there back then. If you wanted to send me a piece of mail, you would send it to Peter Lenz in New York City. Except that's probably not going to get to me, because what if there's another Peter Lenz? What if the postmaster has no idea who Peter Lenz is? So you put in hints. You're going to send it to that Peter Lenz guy in New York City who really needs a haircut, who works in that tall gray building on Park Avenue with a wizard clock out front. You're going to have to give lots and lots of hints. And eventually, maybe the mail will get to you. Abysmal delivery rates. Definitely not 9 nines. We're thinking maybe 7 sevens of accuracy. I think I should patent that. That should be an idea. 7 sevens of accuracy. System got better, though. Within a couple of decades, the post riders were gone. They're replaced with stagecoaches. The stage in stagecoach is the distance between main post offices. And the government stopped using people's pubs and inns as post offices and started building real ones. A process, by the way, that has not yet actually finished. There are still general stores that are also post office. In fact, we're only a decade out from the last instance of a post office in someone's living room. It's a remarkably complicated and interesting system. Anyway, these post offices, main post offices that are being written between, are going to look something like this. There's a whole bunch of different sorting tables. There's all sorts of different ways that you can take a look at the mail. But it's still basically the same idea that Ben Franklin set up. You open up a piece of mail, you go through it. These ones are for here, these ones are for someplace else. And you put them through the bags, into different bags. The bags that are going somewhere else get sent off by various systems. If you're in a big city, these giant tubes here are pneumatic tubes. The mail goes in, and it'll be sent through by a giant steam vacuum through the streets to another main post office, where they will open up the bag, and they will sort. These ones are for here, these ones are for somewhere else. Every node sorts the mail itself. New York City still has these in the street, though they haven't been used in something like 60 years. They're there, though, and they're cool. I like cool things. If you're a little farther apart, you're going to get sent by something like this. It's called a railway post office. It's a really simple system. There's a guy, he's throwing the bag of mail that's being delivered to this town, and we have the outgoing mail here on what's called a hoop. There's a big metal hook right there in the door. What's going to happen is that hook's going to catch that bag, As the train goes past without stopping, that guy's going to pull in that bag, and inside the train car is a miniature version of that post office. They're going to open the bag up, they're going to sort the mail, they're going to bag it up, and it's going to go off to the next place where they're going to open it up and sort it again. It's literally, if you want to think about it as an algorithm, it's a recursive algorithm. Every place you go to, you open the bag of mail, you sort it. If it gets delivered here, great. If not, you put it in another bag of mail and you send it off someplace hopefully closer to the destination. No guarantee of when it's actually going to get there, but eventually it will. The system lasts a long time. This system of main post offices and railway post offices lasts almost 100 years. It's really resilient. And it requires no centralization. Every node makes a decision by itself of how it's going to sort the mail. No centralization whatsoever, but it works. And your address is going to look like something like this. This looks remarkably similar to what we have today. Suddenly, instead of putting a hint about the guy who's going to pick up the mail, you actually have an address, but you still have a city and the state. System is really resilient, works for a long time, but by the early part of the 1930s, it's beginning to show that it's wearing down. They try crazy things to try and patch it. Airmail comes into existence. And in the very early days of airmail, they treated it the same way they treated the railway post offices. Guy throws out a bag of mail as he flies over the town, and there's a hook, and he tries to grab the mail so it can fly off to somewhere else. Basically, it's a way of, instead of having those sorts at each post office, I can make a direct link between two big cities. But it's an expensive system, and it's a hack. It's sitting on top of the existing system, both a part of and a part of the regular routing. And it's expensive. When it starts off, it's a whole 3 cents more than the regular 3-cent stamp, double the price. Crazy expensive. But it works to keep the system working for another 2 decades or so. By the 1950s, they're looking for another cheap fix, another system that they can build on top of it. And being the 1950s, early 1960s, why not strap it on top of a giant missile? They actually did this a handful of times before somebody said, "Holy shit, we're strapping mail on top of a missile. What are you doing?" Each launch cost something like $15 million and cost, it carried somewhere around 250 pieces of mail. I'll let you do the math. I love this one. The post stamp is actually a warship that launched the missile, and it's addressed to James A. Farley, postmaster of New York City, after whom our main post office, the big fancy building across from Penn Station, is named after. Note though, no zip code. It's not here yet. We haven't come to the real solution. Luckily, while the insane people are trying on putting mail on top of missiles, smarter people, let's call them proto-data scientists, are thinking about this problem too. And they implement a hack that actually works. They say we have cities, and one of the big problems is that most mail goes to cities, and they just go there. New York City is a big place. It means we have to sort the mail a lot of times when it gets there. Let's take the concept of city and shrink it down. Let's make smaller cities. So here's an example of the first one that was done, creating postal delivery zones. This is Detroit, except it's not Detroit. This is actually, as far as the post office is concerned, 30 different cities. The cities of Detroit 1 through Detroit 30. And your address will look something like this. I've now changed New York to New York 16. New York City has ceased to exist. Instead, we have 16 city-like things that are numbered. I really love this. This is the hacky data scientist solution that I think that I would have probably come up with. Or at least I'd like to think I came up with. We take a thing that people were already familiar with, cities, and we made this other parallel thing that looks very similar, but is not quite exactly the same. but it worked. It allowed post offices to be much more efficient about their routing. Instead of sending something to New York City and having it to be resorted dozens of times to get it to its destination, it's New York 16, and whatever post office is in New York 16 will actually make the decision of how to decide it. For the first time, we've introduced centralization and some kind of routing algorithm into the postal system. Post office loves it. It really is great. They want to extend it everywhere. So they come up with the Zone Improvement Plan, which again, after millions of dollars, they changed to zip code. This is all of your faces right now. You know what a zip code looks like. You were born knowing what this thing looks like. But how does it actually work? What the hell is a zip code? So this little graphic comes out 1963 as the zip code is introduced and has the virtues of being correct and all of the pain points of explaining absolutely nothing. So let's dig into what a zip code really is. It's not a number. They're routing instructions. It's a topology. It's a way to get mail from one place to another, and that's it. So this is a description of the last two digits. A route from an individual post office to what's called a sectional center facility, and I will keep saying that word, but when I say it, you can just think router. This is like a router in a computer network. It decides where to send things. And there's a bunch of these. Every time you jump between the first three digits of the zip code, you're in another one of these trees. It's routing instructions. Mail goes up one part of the tree, hits the apex point, gets routed to another tree, and comes back down the other side. It's really simple. A zip code is just two things. It's the sectional center facility that you're going to send the mail to, and then the destination after that. So hypothetically, when you send a piece of mail, it starts off at one post office. That post office doesn't care where it's going. It's going to send it to its sectional center facility that's assigned to it. Doesn't care. The SCF decides the routing. Every SCF knows how to get mail to every other SCF, and they have all sorts of logistic systems to do that. Airplanes, trains, boats. There's actually a post office that is still linked by donkey train. It doesn't matter. All of that is hidden inside of the zip code. Every post office knows, sends their mail, outgoing mail, to this SCF. SCFs actually make the decisions. It pushes knowledge upwards. We are gone from the old postal office system designed by Ben Franklin where every node had to be smart, and we've gone to a centralized system. I really love the idea of this. It's a topology. It's not a geography. In any case, this works. This eliminates a massive amount of waste in the system. It speeds things up. Post office wants everybody to use zip code. And so they go on a propaganda spree. They invent this guy. It's called Mr. Zip, and he is everywhere. He is inside of all sorts of posters. There are toys. This bottom one is from my personal collection because I am a complete nerd. There is a Miss Zip Code competition because it's the 1960s, and that's the state of gender relations at that time. I didn't make it up. There's even an entire music video. They put together a band, and it is retro-tastic, and you should look it up. It is on YouTube. But make sure you leave your speakers on low. Ask me how I learned that one. So, zip code begins 1963. By 1967, almost every person in the United States is using it. But that doesn't really matter because most mail doesn't actually come from people. It comes from businesses. And businesses have zero incentive to actually switch to this thing. So the post office introduces one. And it is the reason why we're here today. So the post office says to the bulk mailers, the people who are actually send the vast majority of mail in the country, they say, we're going to give you a cheaper rate on this. We're going to let you send mail for fractions of what a stamp actually costs. But you've got to send to everybody in the zip code And that is why we're here today, because it completely changes business thinking. Instead of thinking about individual people or towns or your existing customer base, you have to switch your thinking instead to zip codes. Instead of thinking about individual people, you're now thinking about these limited number of characteristics that the post office lets you divide by. Suddenly, zip code stops being a topology, a way for sending mail from one place to another, and becomes a fake-ass geography. Except it breaks all the rules. I promised there would only be one slide of actual work here, and this is the one. Tobler's first law of geography. This is the basis of geography as a quantitative science, and it's incredibly simple. Everything is related to everything else, but nearer things are more related than distant things. Well, this means two things. First off, if you're a statistician, say goodbye to the concept of independence of variables. Geography says every variable is related to every other variable by simple virtue of being on Earth. Independence has gone away. Sorry, bye-bye classical independence. But you could pretend it's not there, you know, because it kind of makes the math easier. There's a specific formulation of this that's called spatial autocorrelation, and it relates to how you make a polygon. So you notice what I've not done this entire presentation is I've not shown you a map of zip codes, because my fundamental thesis is that zip codes are not really polygons. They're routing information. Time to break that. Here's a bunch of zip codes in Washington, D.C., and this is literally a screenshot of one of Dstilery's tools for looking at things by zip code, because we work with these bulk mail companies, and they are utterly obsessed with zip codes and other bulk mailing things. It's how they make their money. When you're doing an analysis and you're looking at zip code, you have to ask yourself, what is it that I'm actually looking at? A polygon is a type of classification. Now, if you're doing classification problem, you're going to do it on something that you're actually interested in. You're going to classify on some feature that's related to your work. When you use zip code, you've completely screwed that over, because the thing that actually characterizes the central theme of a zip code is what post office that it goes to. Unless you're really caring about that postal system, like the bulk mail companies who came up with this idea did, you've introduced some weird variable into your system. It's an unconscious bias that is about the size of bags of mail and how big trucks are. It has nothing to do with the actual thing you're talking about, which is probably some human geography problem. You've removed the humans from it and made it about logistics. That's not a bad thing. You know, you can do a lot of things with that. Lots of things have been done with zip codes, but you gotta be aware of it. And having now done this data science game for a few years, nobody really is. You just take zip codes and say it's a zip code. A zip code is a zip code is a zip code. It's not. You've got to know what it is. You've got to think about what you're actually doing to your data. This is exactly the same as if you're classifying on something completely unrelated. You know, the people who live inside these zip codes, they have nothing to do with one another, really. You need to really think about that. Luckily, there are other options that you can use. Oh, and here's one of them. If you absolutely have to stay inside the postal system, the post office provides an even smaller geography. I take that back. Let's not say geography. A bunch of points. It's called zip plus 4. In theory, a zip plus 4 is somewhere between 12 and 18 households, although I recently came across one that was 2,000, and I have no idea how that came to be, but they're in there. They're weird quirks. Anyway, hypothetical. This is a random block in Cape May, New Jersey, because I like Cape May, New Jersey. And here is a zip 4 in this area. Notice how I'm representing it as an actual shape. It's a bunch of points. These are individual households. They're still not a shape or a geography that you can, pump into a GIS and generate data back on. They're lists of locations. At best, you can make it a line. But even that is not perfectly simple, because there's other lines in there, other zip plus 4s that are overlaying it. This is not an atomic system. You can be in multiple zip codes. You can be in multiple zip plus 4s at the same time. This is not a 1-1 mapping. There's a couple of other gotchas you need to know about the zip code system. Some of them don't actually exist. There's no physical location. When you mail your taxes off to the IRS every year, it has an address. Your mail is not going to that address. That routing information simply tells the post office to take that data and send it to any number of different facilities across the country. It's not a real location. Zip 4s are really messy. Dstilery currently occupies 3 different floors of a building at 470 Park Avenue. Across those 3 floors, there are 4 different zip 4s. When I was making this slide, I had many options that I could actually pick from, and all of them will be delivered to the same location. Zip codes are not atomic. A great New York City example is actually Ridgewood, Queens. Go Ridgewood, I'm from there. Ridgewood can be reached from a Brooklyn zip code into Queens zip code because historically it was in Brooklyn. And the system is got a really stupidly long memory. Something that happened 100 years ago is still recorded in it today. And your mail will get delivered both ways. And those locations can show up in either way in your system, not a 1-1 match. Finally, just because you're inside of a zip code doesn't mean you're inside the United States. There are in fact 5 other countries with historic relationships to the United States that use the zip code system. So good luck figuring those out. They don't make any sense with the number systems seen anywhere else. Every US embassy has a zip code, and they're definitely not in the United States. Finally, there's an entire parallel mail routing system that's maintained by the United States military, which has all sorts of quirks, like Africa is part of Germany. In places where it move because the troops themselves move. It's a really complicated system. People tend to take it as a zip code is here and it's never going to move. That's not exactly true. There are alternatives, things that don't really move, things that actually are meant to be used as geographies. Census provides the best of them. Of course, there's census block and track, which I'm sure we're all know about, but there's also something called the zip code tabulation area. Post office has certain characteristics that they sell on to the bulk mail companies, and census is actually responsible for making them, and ZCTAs are how they generate them. Census are a bunch of super geography and super demography nerds. I love them. They know about all the things that I'm talking about today, and they've designed ZCTAs to work around them. They eliminate a lot of the issues that we have with using zip code as a geography. The problem is they're not exactly perfectly matched. Your actual zip code in the ZCTA that you're in can be different. And there's no real way around that except just knowing where the quirks are. Finally, there are a mess of different companies that sell all sorts of different custom geographies and custom data sets for zip code and for zip plus 4. But you need to vet your data. I've seen, and I've bought a lot of this data over the years, and the quality varies wildly. You will find incredibly professional companies that spend a lot of time actually making sure the data is right, and then you'll find Bob's Discount Zip Plus 4 Company, which is the actual name of a company that I was once required to buy data from. I'm not kidding about that. The data was just as good as it sounded like. Believe me. Zip codes. Continuing my rant about different geographies and how people abuse them, we're going to change to something a little bit different because I still have 8 minutes left, and this is a 40-minute talk. We're going to talk about trap streets and trap places. This is very different. Zip codes, you have all the data, and it's your analysis that can make issues with it. This is something else. This is something else altogether. This is where you cannot trust your actual data. You see, once upon a time, companies making maps would copy from each other. And by once upon a time, I mean right now and forever. So to catch one another, companies insert fake data into maps. And this here is the most famous of them all. Right there in the middle is Agloe, New York, which does not exist. It has never existed. It is, in fact, the initials of Otto G. Lindbergh and his assistant, Ernest Alpers. They combined the initials of their names, and they made a fake town, and they stuck it on a map while they were working for a company called General Drafting in the 1930s. If it showed up on any other company's map, aha, we got them. We can go to court, and we can sue them. Intellectual property theft existed back then, too, and this is the only way you could catch it. Fast forward to the 1950s. General Drafting is looking at a map of their competitors, searching for these things. It's a company called Rand McNally. They're one of the largest map makers in the world. And there is Agloe, New York, right there, clear as day. They bring them to court. You guys have stolen data off our maps. And Rand McNally is very taken aback. Like, no, we didn't. We sent surveyors out, and we actually went out, and they recorded it, and here's the photos of Agloe, New York. And they're actually photos of Agloe, New York. And everyone is like, what? What the hell are you talking about? We made this place up. It's fake. It's documented in our data. The problem is that they put it on a map. And the people living there read that map and discovered they're living in Agloe, New York. So this is the Agloe General Store. The photo, I tried to find a photo of this that was good quality of the day, but it used to say right across the top, blue and white, Agloe General Store in Agloe, New York. The thing is, they sold SO Gas, which is today ExxonMobil. And ExxonMobil printed maps for drivers, and they licensed that map data from the General Drafting Company. And they opened up the map. Oh, hey, I'm in Agloe, New York. Let's go and let's put up all sorts of different signs about the place. It's the craziest thing. It's fake data inserted into a map that became real. And here's the thing, it's not gone yet. I pulled this morning. This is the GNIS, the Geographic Names Information System. This is maintained by the USGS and the National Geospatial Intelligence Agency. This is the official list of names of every place in the United States of America. Yes, there is a list. It does exist. This is it. It's online. Here's Agloe, New York. It still exists, even though it never really existed. It's still there. Okay, that's great, you know. There's way more instances of these things. They're everywhere. They're still inserted into maps to this very day. OpenStreetMap recently inserted a few, and lo and behold, there they are in Apple Maps and Google Maps. You know, it's legal, but it's interesting to see that they're copying that data at the time without telling everyone. Since then, they've been forced to actually insert the OpenStreetMaps acknowledgement where they actually pull that data. And even then, for very famous things like Agloe, which I was taught my first year of geography, it still gets into systems. Hey, Google. Still there to this day. So, right on time. I like when that happens. If you guys walk away with any one thing from this talk today, I want you to do two things. First of all, well, one thing. Think about your data. Data isn't just data. It's not just things sitting in a file that are meaningless and have no connection to anything, especially geodata. Geodata is real-world data. It is literally real-world data. It is connected to things that exist in the real world. You have to think about it. Don't just throw statistics at it. Don't just throw it into a model. Think about what your data really means, where it came from, and how to respect it, and also be a little bit wary of it. Anyway, my name is Peter Lenz. I am incredibly tired this morning. I am Senior Geospatial Analyst on the Analytics team at Dstilery, Inc. Does anybody have any questions?
So it's funny, we're actually doing a migration from a third-party SMS provider who kind of has extrapolated location data with...
I'm so sorry, and I feel your pain.
Yeah, with a lat long. So is there a cross-reference, because one of the next things after we migrate is how accurate is this for people who we don't have address information on their users? What are some of the sources, whether public or private, that are best to kind of go through a step-by-step process and vet across other data points?
So you're not the first person to have this problem. This is the basic problem in doing geoinformatics. Luckily, there is a group called GeoNames. They are, as far as I'm concerned, the canonical piece of location data. GeoNames, it's geonames.org. They actually cull through things like the GNIS and the equivalent in other countries and collate the best of that data into a single database. There's no single official geospatial database for Earth, but that's as good as you're going to get. That's the first place I would start. The second thing that I would take a look at is I would actually look at the data itself. Depending on how, you said it's lat long data, correct? I would look at the actual lat longs themselves. You can apply the same algorithms that are used for finding false financial data to lat longs. This is something that I developed for Dstilery, and you can actually find things that are truncated lat longs, rounded data, fake data in the system. And there's a number of different algorithms that can do this. If you want to geek out during office hours, we can offline this. But they work exactly the same way. Financial fraud modeling software works great on location data. Howdy.
Thank you. In a previous job I worked a lot with geographic data, and they're the same problems you're talking about. The political and geographic visions work different in different countries. I used to work for the UN, and different countries organize data in different ways.
In fact, you could have the exact same data just by crossing a border. It looks different. If you look at Google Maps in India, it looks very different than Google Maps in Pakistan.
Yeah, and disputed regions appear differently in different parts of the world. So it's a big problem. Now, well, I was doing, anyways, one common technique people use kind of grid the world or use different kind of mathematical spherical techniques to slice up the globe in either squares or other form of geometry, and then use that as the canonical reference instead of some sort of population distribution or political distribution. Do you guys use anything like that? We
actually do. We built a system called Geo Tiles that puts everywhere on Earth inside of a 100 meter by 100 meter square using a NATO standard. It's called the MGRS algorithm. It's blindingly fast. It's written in C, and we actually use that to put all location data inside of a cell. On top of that, we have a second GIS that actually is point of interest data, actually polygons of store boundaries and things like that. So we actually contextualize that data both ways. And that's really valuable because most things do not happen about places that you know about. They happen at people's houses and parks and on the freeway. And if you're just looking at it from a point of interest point of view, you're losing much of the story. The other thing that's great about that is that when we do find a new place and we load into our point of interest database, which is 3.5 million places about right now in the US, we have histories of that location to some degree inside of this grid system where I can go back and say what happened in these grids into the past. It used to be before we had that, I could only start telling stories about places once we found out about that place. Now I can have histories. I love histories. Histories can be learned on.